Determine the sum to infinity of the following infinite series. Let us begin. Now here, this particular series is not an arithmetic series. That's because we cannot find here a common difference. We can pick up any term in the series, and if we subtract the previous term from the series, the difference is not going to stay the same. Similarly, this is also not going to be a geometric series because here we cannot find a common ratio. However, this particular series is composed of an arithmetic sequence and a geometric sequence. To understand this, we're going to rewrite each of the terms. So our first term, we keep it as it is. We have 3 over 2. Add it to. Next, we have negative 5 over 6, but we can rewrite it as 5 over 2 multiplied to negative 1 over 3. This gets added to 7 over 18, but 7 over 18 can be expressed as 7 over 2 multiplied to 1 over 3 squared. Then we have added to it 9 over 2 multiplied to negative 1 over 3 cubed. So this way we have infinite number of terms. Now here let's look at each of the terms carefully. Now here for this particular series, if we consider the first term with having value 3 over 2, the second term being 5 over 2, third term being 7 over 2, fourth term being 9 over 2, and this keeps on going. This is going to be an arithmetic progression. So this particular series or sequence is an arithmetic progression. So here we can clearly observe that the first term, that's 3 over 2, and the common difference d, so that's going to be equals to 1. And if we consider from the first term we have 1, from the second term we consider negative 1 over 3, from the third term we consider 1 over 3 squared, from the fourth term we consider 1 over negative 1 over 3 cube. Then these terms are going to be in geometric progression with the common ratio are given by negative 1 over 3. Fine. So here this particular series is actually an Arithmetico-Geometric series. Now here, to find out the sum, what we'll do, we're going to consider S as the sum to infinite number of terms that will be equals to, so we rewrite the terms of the series. We have 3 over 2 minus 5 over 6 plus 7 over 18 minus 9 over 54 added to the rest of the terms. Now here, what we'll do, we'll take the same sum up to all the infinite terms, and we're going to multiply each terms with the common ratio, which is negative 1 over 3. We're going to multiply S infinity with negative 1 over 3. So that means we now have 3 over 2. This is the first term. When multiplied to negative 1 over 3, so that's going to give us negative 3 over 6. But we're going to write it below negative 5 over 6. Then we have negative 1 over 3 multiplied to negative 5 over 6. So that's going to give us positive 5 over 18. Next will be negative 7 over 54, and this is going to continue up to infinite number of terms. Now what we'll do, we're going to perform a subtraction here. So what we'll do, we will take the sum to infinite terms, and from here subtract negative 1/3 of sum to infinite terms. On the right hand side we have 3 over 2. Now negative 5 over 6 minus negative 3 over 6. So negative 5 over 6 minus negative 3 over 6. So this is going to give us negative 2 over 6. Then 7 over 18 minus 5 over 18. So that gives us positive 2 over 18. Then we have negative 2 over 54. This is going to now continue. So on the left hand side, we're going to have 4/3 of S infinity, that will sum up to infinite terms. This will be equals to 3 over 2. Now, if we consider the second term and this third, fourth term, that means sum of all the terms excluding the first term, this is a geometric series. Now, for this geometric series, the first term, that's going to be negative 2 over 6, or simply put, that's negative 1 over 3. To find out the common ratio, we're going to consider the second term of the series, which is 2 over 18. And we're going to divide it with the second term, which is negative 2 over 16, or simply put, we're going to multiply it with negative 6 over 2. So here 2 and 2 gets factored out. 6 times 3, that's 18. So that means our common ratio comes out to be negative 1 over 3. And we know that the sum to infinite terms of an infinite geometric series, that's given by a over 1 minus r, which means that now we have added to negative 2 over 6, that means we have negative 1 over 3, that's the first term, divided by 1 minus negative 1 over 3, or we can say negative positive 1 over 3. So we get 4/3 of s infinity equals to 3 over 2 minus, so here we have 1 over 3 divided by 4 over 3. So that gives us 1 over 4. So 4 over 3 s infinity, so that's equals to 3 over 2 minus 1 over 4. So that's going to give us 5 over 4. Now we are going to multiply throughout with 3 over 4. So as sum of the infinite term, that comes out to be 15 over 16. So this is the sum of the infinite series.